Here's a video explanation of some of the things we'll be thinking about in section 2.5, solving linear inequalities. How do you solve a linear inequality? You're going to have, in this case, the triad example is 6x is less than 10x plus 19. The idea of solving these things is you just want to do your normal algebra things, adding and subtracting constants and things from both sides of the inequality, multiplying both sides of the inequality by the same value, or dividing both sides by the same value. The only trick is if you multiply or divide by a negative number, you have to change the order of the inequality, and I'll explain that in this example. As you do this, you have a typical goal of getting the x by itself, and you can either move the x and the terms with an x in it to the left side and move everything else to the right side, or you can move the x's to the right and move everything else to the left. It really doesn't matter. Sometimes the algebra works out a little bit easier with negative signs if you do it one way versus the other. But let's try both ways here. So if you want to move the x to the left and you start with this example of 6x is less than 10x plus 19. First thing, you subtract 10x from both sides. 6x minus 10x is your 4x is less than 19. And then to get x by itself, you have to divide by -4. And when you divide by a negative number, that multiplies everything by -1, so it switches the direction of the inequality from the less than that it was to a greater than. And so you end up with x is greater than -19/4, which is an inequality solution for what we want. If instead you had, back at the beginning, decided to move all the x's to the right, you could do that too. So start back at the same inequality, but in this case, we're going to move the 19 to the left side, so we subtract 19 from both sides, and then we subtract 6x from both sides to get rid of those x's on that side. And we end up with -19 is less than 4x. 10x minus 6x is our 4x. So here's our solution. And to get x by itself, the last step you have to do is divide both sides by 4. But since 4 is positive, you don't have to change the inequality from a less than to a greater than. You just keep it as -19/4 is less than x. And if you think about it, these two inequalities are saying the same thing. Either x is greater than -19/4, or -19/4 is less than x. That's like saying I'm taller than my son, and it's the same thing as my son is shorter than I am. Those inequalities, if you say them in the opposite order but change the less than to a greater than, they're both equivalent. And when you graph that, so -19/4 turns out to be -4.75. And so the key point on your number line is right here at -4.75. And the interval we're looking for is then all x is bigger than that. So you have a parentheses, all numbers up to really, really close to -4.75, but not equal to -4.75, and anything to the right, anything more to the positive side from that. And if you think about that in the kind of reverse inequalities where with the x on the right-hand side, that's saying the same thing. Whatever your number is that's a good number for your inequality, -19/4 should be less than that x. And so it should be to the left of everything you've got, which is all those orange intervals. There are a bunch of examples in the book that are slightly more complicated algebra, but really no different. All you have to do is multiply things out, distribute across parentheses if you need to, combine like terms, and then move all the variable terms to one side, move all the constants to the other side, and solve for your variable. It's 4 simple steps, but some of these, there's a lot of algebra involved. So let's talk this through. First, we want to distribute the 7 and the 8 through our parentheses. And be careful with your negative signs, and I'll try this. So -7 times 2 is -14. -7 times -h is positive 7h. That's going to be less than. Distribute the 8 through. 8 times h is 8h. 8 times 11 is 88 plus 8h. Now let's combine stuff. So we've got 9h plus 7h is 16h minus our 14 is less than, and on the right hand side we've got 16h plus 88. And then what do? So now you move all the h's to one side and move all the constants to the other side. So let's subtract 16h and subtract 16h. And in this case, what happens? In this case, the 16h's cancel each other out and the h's disappear. If they hadn't disappeared, you would end up with something like 3h is less than 88. You divide by 3 and get your inequality. If you had ended up with a negative number times h and you divided by that negative number, you'd have to remember to switch the inequalities. But in this case, the h's go away. So what do? That means this is true no matter what h is equal to, right? Because negative 14 is always less than 88, it doesn't matter. So we ended up with a true inequality, so the interval is negative infinity to infinity is the solution. Any value of h will make this a true fact, because the h's cancel out and they don't really matter. If some of these problems you work through and you had ended up with negative 14 is greater than 88, which is not true, then the solution would be no solutions, right? There would be no value of h that would make that true because, again, the h's all cancel out and you're just left with this fact about numbers. In this case, we're left with a fact that's true. Sometimes you'll be left with a fact that's false. And so that would have no solutions. The last thing I wanted to mention is there are several problems in here that are real life problems. And let's read through this one and then I'll talk through a strategy how you can work with these. So this is a try it in the book, and there's several homework problems similar to this. Caleb has a pet sitting business and he charges $32 an hour, which I have to admit, I didn't realize you could get that much money for pet sitting. His monthly expenses are $2,272. How many hours does he work in order to earn a profit of at least $800 a month? And as soon as you see at least something or at most, you're going to end up with an inequality. And so when you see a word problem, you've got to think through what are the concepts that I'm really worried about. And they want my profit to be at least 800. But I also know that my profit is my income minus my expenses. So I can rewrite that as income minus expenses is greater than 800. Well, what are my income and my expenses? They tell me my expenses are $22.72. What's my income? Well, what's my variable? If so they ask me then to find out the variable, look back at your problem and find out what the question is. How many hours? So let's say X hours. And that is a key in almost all these word problems. Whenever they say how many or how much or how long, that's your variable in a lot of these cases. So if we work for X hours, we're going to get $32 for every hour. And so we get 32 times X, and that's dollars we've earned. That's our income. Minus our expenses has to be at least 800. So how do we solve that then? Well, so that's our inequality. How do we solve it? By adding 2272 to both sides. And you get then 32x is greater than 800 plus 2272 is 3072. And then I have to divide both sides by 32. And you get x is greater than 96. 96 what? 96 hours. So Caleb has to work for 96 hours each month to end up with a profit of at least $800 per month. Hopefully that sort of thought process and that way of thinking about inequalities is helpful. We'll talk about examples in class, and then we can work out a lot of examples together as a group.